Hello everyone and welcome to lab number 4 about circuits and capacitors. With me, your host. Well, we've all seen circuits before, sometimes in our lives, in our school, but now let's break it down to its most simple components, currents and resistance, as well as capacitance and potential difference. Yeah, we'll be using these basic building blocks, kind of how we'll get snap circuit. The purpose of this experiment will be to predict the behavior of circuits containing resistors in series and parallel, to use multimeters to measure the actual values of conventional current and potential differences in the current in the circuits, and to examine the behavior of ohmic resistors and capacitors. The initial experiment of this lab was to take a look at putting two batteries next to each other with 2 ammeters and 2 resistors. And so I created this beautiful little half star shape, as you see on the top. And what I predicted was that the resistance in the top ammeter and the bottom ammeter would be the same. And what do you know? That's exactly what happened. Also, I predicted that switching the ammeter direction would make it negative, and what do you know? That's exactly what happened. And then we were told to remove one of the ammeters and use a voltmeter on both ends of our circuit. And so measuring it, I found that there was a current of 0 and a potential difference of 3 volts. Why is the current 0? Well, it's because that the circuit's broken. There's no water in the river if river not moving, or river is you guys get the idea. Let's move on. So then, in our circuit, as we saw in the previous slide, we put our voltmeter in multiple different locations, and here we see how the potential rises as it goes through the battery and slowly gets used, in a sense, used up in our 2 different resistors, and it drops a lot more over the larger resistor. And of course, an ideal ammeter has no resistance, so we get no potential difference drop over the ammeter. And then when the ammeter is placed in parallel, as we see here, the current only travels through the ammeter when it's placed in parallel with a resistor, because the ammeter basically has zero resistance. Also here, we see how I measured using V over I to calculate R, the resistances in each item, the resistors, and the wire, and the ammeter. Again, due to this being a computer simulation, everything's ideal, so what it says is what we get. Another way we could analyze our toys here was by using lights and capacitors as they charge and discharge. One interesting thing we saw is that when we were charging a 10 ohm versus and discharging through a 10 ohm versus a 12 ohm bulb, it took roughly double the time, which is very interesting, which shows us that the more resistant, when you double the resistance, the current gets halved, which means the speed that things happen is also halved or doubled because the rate is halved. Here are the very important equations that we saw in action in our experiment. We saw V equals IR, but then we also see that through the loop rule, or the energy conservation rule, that Q over C minus I over I times R equals 0. And from that we derive, with using the differential equation, that there is a relationship between the log of the potential difference at one point over the potential difference originally to some constant. It's like an exponential decay kind of deal. And actually, when we do analyze this and graph the relationship between potential difference in time in a discharging capacitor, what do you know? It's actually an exponential relationship as we expected. Some interesting things to think about: if we use a real ammeter, the real ammeters actually have a little bit of resistance. So that would have tweaked some of the numbers because, things aren't ideal in the real world. Same thing, if we used a real body to charge a capacitor with no resistor, we would still get a different number because normal wires actually have resistance, just really small resistance, but still some resistance, and that would have changed the expected value. All right, in conclusion, we understood the formula and used it to calculate and predict current and potential difference. The next step is to harness it for world domination. Thank you, and I'll see you in the next one.